The broadcast is now starting. All attendees are in listen-only mode.
Hi, I'm Krista Campbell. Before we get started, I would like to encourage you to ask questions. You can post your questions in the questions dialog box at any time during the webinar. We will have time at the end of the webinar for Q&A. This webinar is being recorded and will be posted in the water utilities space on GeoNet as well as the Esri Water Meetup group. You will receive a follow-up email that includes links to these locations. It takes a few days, maybe a week, to get the webinar published, so you can expect it to be available towards the end of next week. Thank you for joining us today for supporting Stormwater with ArcGIS. In today's webinar, you will learn how Esri can help with the collection of assets to support management of your stormwater system. Presenters will discuss best practices and ArcGIS configurations that will help you map your system. Joining me today is Mike Miller, Howard Crothers, and our special guest, Nicole Beck. Mike Miller is an experienced information technology professional with expertise programming and designing enterprise GIS solutions with Esri software. He has worked at Esri for 18 years, supporting a wide variety of industries ranging from cadastral to public safety. For the past 14 years, Mike has focused on GIS deployments in the utilities industry. Currently serving as the Utilities and Telecommunications Solutions Lead for Esri Solutions team, Mike is responsible for the technical efforts to create industry-specific solutions for Esri customers. Mike has specialized experience developing mobile applications, desktop, and web applications. Howard Crothers is a product manager in Esri's Solutions division and is responsible for Esri's utility and telecommunications templates. Howard has over 20 years of experience using GIS to support utilities, public works, and AEC companies. Nicole Beck is the CEO of Second Nature and has a PhD in aquatic chemistry. She has dedicated her career to figuring out how to bring science to decision makers. With over 15 years in stormwater consulting, Second Nature has landed on providing scalable geospatial software solutions to simplify regulatory compliance and accelerate effective stormwater programs. Before we get to our team of presenters today, we're going to have a couple polling questions. If you would just take a second to answer our first poll, what percent of your stormwater network do you have mapped? Less than 25%? 25 to 50%, 51 to 75%, 76 to 100%, or maybe you don't have your stormwater network mapped yet. So far, it looks like about 40% of you have a majority of your network mapped. I'm going to give you guys just a couple more seconds to vote. Looks like we're still missing some of you. What percent of your stormwater network do you have mapped? All right, so we have about 12% that have less than 25%, 13% are between 25 and 50, 14% are between 51 and 75, 37% are reporting 76 to 100, and 25% of you are saying you haven't gotten started yet. All right, we're closing this poll. We're going to move on to one more. What is your primary focus on stormwater? Asset inventory, inspections, green infrastructure, or other? What is your primary focus on stormwater? So we just want to learn how you're using your stormwater system and why you're building it and mapping it. It looks like about 40% of you are reporting that you're using it for asset inventory. We've got about 26% for inspections, 14% for green infrastructure, and the rest of you have chosen other. If you'd like to comment in our comment box about how you're using your primary focuses on stormwater, please feel free to do that, and we may discuss that in our Q&A session. Okay, thank you everyone for taking the poll. We're going to go ahead and pass the presentation to Howard Crothers, and he's going to get started with our topic today. Howard?
Thank you, Krista. hopefully everybody can see my screen. If not, I'm sure someone would be good enough to let me know.
I can see it.
Excellent. So what Mike and I wanted to focus on during this webcast was two questions that our team commonly gets about stormwater. Those questions are, does Esri have a stormwater data model? And does Esri have templates for MS4? So let's start taking a deep dive into question number one. Does Esri have a stormwater data model? And the answer to that is yes. In fact, Esri has multiple stormwater information models and a whole lot more for stormwater. And that's because ArcGIS includes templates for stormwater. What these templates provide you is stormwater-specific productivity tools. They provide you stormwater-specific app configurations. They support stormwater-specific workflows, so common workflows that organizations that have to manage information about stormwater systems need to do. As well, they provide you foundational information models, and these are tucked into a few of our templates. And we like to use the term information model now as opposed to data model. Information model because what these information models really provide you is, yes, a schema, right? So you can think of that a lot like your data model, but they also provide you maps. They provide you services. So the maps and the services are what lays the foundation on top of the schema of your organization to make the data come alive and be accessible to everybody that needs it throughout your organization. Now, ArcGIS actually includes a number of stormwater templates. We're not going to be able to get into all of these today, but I just want to show them to you to let you know that they're there if you haven't seen these before. And these stormwater templates range in function from things like general purpose apps that you can stand up, like a stormwater system viewer for anybody in your organization, or maybe a simple app to let folks do things like contribute red lines back to your GIS staff to let them know maybe what data needs to be edited, to a set of templates that help you engage better with the public. Actually, a template that I really like is Adopta, if you haven't seen that, which helps you engage the public in things like maybe maintenance activities around your catch basins, like engaging the public in adopting a catch basin and having them go shovel snow maybe off of the catch basin, or rake leaves, off of the catch basin when leaves are falling. We have a number of templates that help you manage information about your stormwater conveyance systems, either as a network or as a set of simple features. We're going to dive deep into this in a minute. We have some templates to help with capital improvement planning and communication around your capital improvement projects. And as well, we have a number of templates that help your folks in the field do their job better, inventory your assets, do inspections, things like that. Now, those stormwater templates I just talked about are free. So if you didn't know that, ArcGIS includes free stormwater templates. You do now, because these are free for you to use on top of your ArcGIS licensing, and they're fully supported, meaning that as part of your organization's Esri maintenance agreement, you actually get support on all of those free templates, and that's available to you at no additional cost. Those templates are updated and enhanced. So what our team does is we test them at new versions of ArcGIS, we bug fix them, we patch them. We also enhance them. We add new capabilities to them based on the request of our user community. So based on your requests, we will continue to put more functionality into the templates that we have. All the templates that we have are documented for a do-it-yourself style of implementation, meaning that they give you very detailed instructions on how to deploy it yourself. If you do need help deploying these templates, we encourage you to work with either Esri business partners or Esri professional service that can help you get these stood up. These stormwater templates are part of a much larger collection of industry-specific templates. We have about 450 templates that range across 9 different industries. We like to refer to those templates as ArcGIS solutions, and the place to go find these and discover them are solutions.arcgis.com. So the templates I just showed you on the previous slide, what you're going to see Mike demonstrate in a little bit, when you want to get those, you go to solutions.arcgis.com. So let's keep diving into the information model. As I mentioned, we have multiple information models for stormwater, and I think of these really in two different categories. We have what I like to think of as contemporary information models. As the name implies, they are designed for today's ArcGIS. And they are included with the Mapping for Small Stormwater Systems template, and they're also included in the Stormwater Utility Network Configuration template. And what you can think about those information models as are frameworks. Frameworks because what we intend for you to do is to build your implementation out from around them. They're not intended for to use them exactly as they are. Yes, you can. But what we anticipate is you're going to extend them to better fit the needs of your organization. So you would extend them to maybe reflect how your system is actually constructed. We're missing asset types in our information model that is in your network, either green infrastructure or gray infrastructure, so man-made or natural. If we're missing any of those, we expect that you're going to add those in to make the information model better fit your stormwater system. We also anticipate that you're going to extend them to better meet your information needs. So let's say that for regulatory compliance, you need to track pieces of information that we haven't included in our information model. Well, you simply extend the model then and add the attributes in that you need to track that are relevant to your organization. We also like to think of them as frameworks because they're meant to support you deploying additional maps and apps as necessary. We can't give you all the map configurations, the app configurations specific to your organization, but what we want to do is deliver this foundational information model so it's easy for you to make those additional maps and easy for you to make those additional apps that present the information contained in your data in the appropriate way to your organization and to the appropriate folks. We also have what I like to think of as legacy data models. And I want to point these out to you because they are still available. And these are contained within the Water Utility Geometric Network Editing and Analysis template. And if you had older versions of the Local Government Information Model, pretty popular, still floating around, those are really the geodatabases. So they're not really rich information models like the contemporary ones that I'm talking about. If you were starting an implementation today, I would encourage you not to start on those legacy data models. However, if you're using them today and you're getting benefit from them, that's the basis of your current implementation, I just encourage you to think about maybe what is the right time in your organization to move to one of the more contemporary ones. You don't have to, but I would just encourage you to think about, in the future, there may be additional capabilities that you're going to get by going to one of these more contemporary information models and also changing your style of deployment. I also want to point out that you are not required to use any of these information or data models. You can always create your own. So if you find that they do not fit at all the way your organization needs to manage your data, you are absolutely free to start your own. These are not a requirement. So what are the similarities between those information models that I talked about? Well, Mapping for Small Stormwater Systems and the Stormwater Utility Network Configuration have a lot of similarities. Though they're deployed differently, we'll talk about that in a second, but they both provide you that schema for storing information about your stormwater systems. And they're both designed to support some very common stormwater workflows: field asset inventory, field asset inspection, editing in the office, map viewing on a mobile device or a regular web browser, or being used in any of Esri's clients. They support map printing, analysis, all those traditional GIS workflows. Really important to know that they are aligned. So those two contemporary information models I talked about are aligned, even though they're deployed in different ways. They're aligned with each other. That makes it easy for you to go from one to the other. And the scenario we really designed this for was for organizations that want to start out with that mapping for small stormwater systems type of deployment and approach, and then move into a more robust implementation that gives them a lot more capabilities by implementing the utility network. So here's the differences between those information models. And the differences are largely driven by the style of deployment and the technology that we're deploying those on top of. Mapping for small stormwater is designed to be deployed in a SaaS environment that is ArcGIS Online. So in that environment, Esri manages the environment for you, the computing environment. It's SaaS. And what Mapping for Small Stormwater does is it turns ArcGIS Online into a web-based stormwater GIS. Mapping for Small Stormwater leverages simple features, so just points, lines, and polygons. There is no network data structure. Therefore, you have none of the traditional network capabilities. So things like tracing, things like topology built into your network data structure are not available through the Mapping for Small Stormwater implementation. It is a very rapid deployment, literally minutes to deploy. But because we are deploying in a SaaS environment, there is limited ability to customize. And you need to be careful when customizing it, because if you are not a savvy ArcGIS Online user, you may do things that break a downstream information product, like break a web map or maybe break an app. So if you're going to extend this or modify it, certainly you can do that. You absolutely want to be careful and test it. There was also no versioning, so you don't have the ability to edit in a versioned environment when you deploy Mapping for Small Stormwater. Now juxtapose that with the Stormwater Utility Network configuration. That's deployed in what we like to think of as a PaaS environment, so a platform as a service if you're not familiar with that term, because you're deploying it into ArcGIS Enterprise. And that's really what ArcGIS Enterprise is. So that means your organization has to provide and manage all of the computing infrastructure, either on your own premise or up in the cloud. It does leverage the utility network. So that's what gives you those really powerful network capabilities. So the ability to trace, the ability to have the network manage topology, the ability to have the network validate data edits. This does take longer to deploy, both longer to deploy the actual act of deploying the configuration. It also takes longer, or it should take you more planning on the front end when you do an implementation, because you want to make sure that you're setting it up, correctly, that you're correctly modeling your own network within that configuration, so extending that configuration. But it is highly customizable. So it's a much more customizable style of deployment, and it does enable you to take advantage of versioning. And with that, I'm going to hand it over to Mike, and Mike's going to actually demonstrate these different templates to you now.
All right. Thanks, Howard. Hopefully you can see my screen, and then you're seeing a map of our stormwater system.
Yes, that's what we're seeing.
Great. Thank you, Kristen.
You're welcome.
All right. So what I'd like to do is we're going to go through and take a brief dive and look at each of these different configurations. As Howard said, they share a lot of similarity and have a lot of overlapping capabilities. So we're going to start out with taking a look at Mapping for Small Stormwater. So this, as Howard mentioned, this is deployed very easily. And after it's deployed, we'll go through the applications and the configurations that are immediately available to you. We're happen to be using our Naperville sample data here, and this will allow us to explore this configuration so you can better understand the capabilities it provides. We'll take a look at the first configuration is a Stormwater Network Viewer. Now this is a simple network viewer taking advantage of a web app builder. It's already pre-configured for you. This is set up to allow your users to explore the information. So you can see the things such as our outfall locations, we can see the pipe network and get details, and review the information associated with them. So nothing new to us that have been using GIS for a while. But this is the data models already pre-configured and set up, and these viewers are set up. This gives us ability, already has built-in searches pre-configured for this. So as we go and want to locate assets, the search capability is already configured for us. We can quickly find a manhole and get into that, look at the information associated with it. As I said, it's designed to be a simple viewer, but let's look at some of the assets we can view in here. The information we've already seen, such as manholes, pipes, but we've also, this data model has been upgraded to focus a lot on the information and the details for storing our BMPs, such as our centralized BMPs, our decentralized information, as well as walls, the pipe networks, and then the boundaries and the extent of those BMPs or the assets in them, such as the ponds or reservoirs. So as a new addition or an upgrade from the geometric network or the model we provided in the past, the local government network, as we've did some work and extended this so we can start capturing this additional information we need in our stormwater system. Let's go back out. A number of widgets are already provided, but if you use Web App Builder before, the beauty is we can easily keep extending this and adding new capabilities very easily by updating and adding widget. One of the widgets we provide is an asset summary, and this allows us to easily see the count and some details of the assets on the current view we're looking at. As we navigate around, we'll see the details change, or we can open this up and explore any of the details and quickly get to that asset on the screen. So the asset summary widget is a very quick widget, allows us to see to count the features and as well as inspect those features on the screen. But a lot of times we need to create an output or create a product or create a paper map for someone to look at or hand out to hand to a different person in the department. By default, we don't include the screening widget, but I was able to easily extend this configuration by adding the screening widget. If you haven't used this before, it's a really powerful widget that allows us to look at counts and do print and make a print map. So I'm just going to draw a simple box around this area. This is going to allow us to run a report on this area, and I have it set up to look at the manholes and the discharge locations, which we don't have any here. But we can easily keep extending this for inlets, for pipes, what other information that we want to report on. This is really great. We can see the information here. The key is we now can select a different landscape or a different layout we want, such as a portrait, hit print, and this information will now be created. Not only will the map be drawn here in a second, but we get that same summary information that we configured in the widget will now be presented on this form, and very quickly we can create a print from this product. And there's our map, the legend, as well as the summary information. So the Stormwater Network Viewer is that framework or that starting place for you to go ahead and start sharing your stormwater information around your organization. We provide some baseline configurations such as the searching, the setup of the widgets with its pop-ups, the configuration of the screening widget, but it's there for you to extend and add additional widgets to make it easier and really meet the needs of your organization. Now this information is great, but how do we update it? How do we go through and start improving the quality and details of the stormwater? We have another configuration of Web App Builder that is looking at the same information, but this time we have the editing widget turned on, or asset editor. So let's go over here and take a look at this high school area. So imagine there's a new some green infrastructure going in this area, and I want to start sketching that in. Using the asset editor, we can start filling out some preset information. This is a nice capability of the Smart Editor widget, where we can we can promote different attributes to the main screen, so we can fill them out once, and then every edit will have that information carried forward. I'm going to search for a wet basin, which I can go ahead and quickly just sketch in the area of our new BMP, save our information, and lastly put a centroid location that represents the details of that wet basin. And here you can see a lot of the characteristics or details we're storing about our BMP assets, such as the ID, the treatment capacity, the drainage area. This is all critical information so we can understand how this BMP is affecting, how this BMP is contributing to our stormwater system. Now, I'm not going to fill that out. We can go ahead and just save that asset for now. But you can see the information that's tied there. The Stormwater Network Editor goes beyond just our BMP assets, but gives us access to edit all the information that's part of that data model, such as the pipes, inlets, and it's not just about creating new information. We can also edit any existing information in our system and quickly update that asset or those attribute details. Now, what we're showing here is this map is presented through a web browser, but the same map and the same services behind it can also be utilized in ArcGIS Pro to provide more of an advanced editing environment. But we're going to highlight that editing can now be done distributed through web applications like this or through our mobile device. So let's switch over. I'm going to be sharing my mobile device, and let's see, it's like it's not connected. Let me try connecting it. Let me restart that. Should be displaying my mobile device. Must have timed out while we're waiting. Now we're back. All right, so now on a mobile device. So some of the other configurations we provide are configurations for let's see if this actually works. Might be having some technical difficulties. It was working a few minutes ago. Now we're back. Okay, so one of the other configurations we provide is a viewing application for a mobile device. Here we're using Explorer for ArcGIS. Here we have access to a number of different maps. Let's take a look at our Stormwater mobile viewer. Here in our Stormwater mobile viewer, happen to start out the same extent as this high school. We can see that same web base and that BMP that I just sketched in with a web application. Now, this application is designed so we can go ahead and start reviewing all those assets. It also has capabilities so we can go ahead and not only review the assets of that information and present it in a nice pop-up like we're seeing here with details, but also interfaces with other applications such as Survey 123, and allows us to go ahead and quickly add information such as a field report. So anyone in the organization now, while they're out in the field, while they're looking at the map, can log in information about an issue they might see. Whether that's a map change request where they're seeing a asset that's missing from the map, or it's abandoned, or some information that's not correct, or an O&M issue, whether that's, in this case, say the manhole cover is missing, which near a high school I'd say is a pretty severe issue, so we can go ahead and mark it as urgent, fill out details, and submit that back, and then switch back to our Explorer. So the viewing of the information is not only for the web, not only for the people inside of our, using a desktop inside our organization, but also for anyone out in the field that could take advantage of Explorer. Other configurations allow us to actually start doing more detailed inspections and inventory of those assets. Let's switch over to Collector for a minute. Here in Collector, we have two other applications we can take a look, or two other configurations we can take a look at. First one of these is the Stormwater BMP inventory and inspection. This is a focused version of this map designed strictly around inventorying and inspecting your BMPs. So we'll go back to that same area. And as we zoom in here, we'll see that BMP. And this time, I want to actually sketch in the pond that's part of this basin. We can select that from our list, just simply typing that in. And I have to zoom in a tad more. And while I was on the field, I could use my GPS to stream it, but I'm here in the office, so we'll just manually click that extent of that pond that's part of that wet basin. Once we're done, fill out the information with it, and that quickly we've now captured that information. This is designed to allow us to inventory the outfalls, the BMPs, as well as also provide different inspections. Let's take a look at that web basin we just added. If we're out there, we can see the details that were captured in the office, which we didn't fill any out, but they would all be presented here. But we also can create a new BMP inspection form, or we can use today's date. We can start detailing what we removed, such as there's trash in it, the equipment needed was just some manual equipment, any notes, any damage, such as there's damage to the trash screen, and any engineer and take attachments. So using these applications, we can start improving the location of our BMPs. So a lot of times the BMPs may be on private subdivisions and not owned by organization. This configuration would allow us to go out and start inventorying them, as well as creating reports about how well they're performing. The last one we'll take a look at here is a Stormwater mobile editor. This presents a very similar set of information, but extends it to allow us to go ahead and do more detailed editing in the field. So if we're in that group that didn't have any of their stormwater assets, this is an application we can use to extend a group out in the field and start locating all the different catch basins, all the inlets, And as we're doing that, start placing them down, as well as even sketching the pipes. So let's go ahead and actually find one of the pipes we want to put in there. In this case, we'll just put a pipe culvert in, and we can use it. We can use our location to get it fairly closely snapped, click the location, and fill out the details. Now, you may be asking, yeah, is that actually truly snapped? And it's not, but it allows us to quickly locate that. Then using ArcGIS Pro or other applications, we can go back in and adjust them to snap the network together. So hopefully this has been a very quick tour, but shows you some of the power of mapping for small stormwater. Very easily, this is deployed into your organization, gives you the data models and baseline app configurations to do the inventory, the editing, the inspections, and start capturing the information and sharing it around your organization. What I'd like to do is switch over and take a look at how the utility network extends and goes beyond that configuration. So here we're looking at a very similar set of information, but this happens to be in ArcGIS Pro, taking advantage of the utility network configuration for stormwater. So let's go ahead and take a look at zoom in on an area. Here we can see the stormwater network. The symbology is slightly different because we have updated it for our utility network configuration, but really the same information. Our inlets are presented here with the details associated with them. We have our manholes with information, with their attribute information, as well as our pipes. The utility network, though, as Howard said, provides a network, a topology of features. And this also allows us to do some more advanced things. At a very simple example. Here we have some roof drains that are on top of the high school, but they're actually drained through going into the storm system somewhere around here. Using the utility network, we can create what is called an association. These are non-spatial connectivity. And if you used our geometric network in the past, we've had to create these virtual drain lines or these virtual connection lines just so we can actually have things flow. That's not required anymore with the utility network. We can associate this location with this manhole or this inlet, whatever it may be. And what this provides us is the ability to go ahead and say add a flag at this location, do a connected trace. And now from this location here, that's not spatially coincident with any of the other features in our network, we can trace through this system and actually see how it's connected to the system. So very simple, but powerful example of what the utility network provides with these non-spatial or what we call associations. Let's clear that and reset. Let's take a look how we can use this in a more complex example. So we're looking at another BMP. Excuse me. Let's move over and take a look at another BMP. In this case, we have a wet basin which actually has two ponds in it, a weir, and then drains out into the river. Now, how is the flow? How is the water flowing through this? What information do we actually have inside of this BMP? We can take advantage of a new concept called containment. So I'll use a tool to say we want to enter the containment of this BMP, and as we zoom in, we'll see additional details start to turn on. We can see the outfall of the outfall of point turn on. We can look at the weir and the culvert running into the river, and how are they also all connected is through those associations. So the containment, if we review what that provides us, allows us to say that in this BMP, we have the ponds, we have the inlets, the outfall, the storage locations, the weirs. These are all assets that are contained inside of the structure. So this is another type of association. It's not just how they're connected point to point, but what things may be contained inside of other features. This allows us to start modeling a lot of the granularity or a lot more details about our assets so we can have a better representation of really what's in our stormwater network. Taking that same trace, let's go ahead and actually add a starting point out here on one of these pipes. And this time we're going to do a downstream trace. And we'll pick our subnetworks. We'll cover what those are quickly in a second. So here we're running our downstream trace. And now we can see we're flowing through here, as well as it's selecting a river and going down. The other thing you may notice is it's selecting our polygons. It's selecting the ponds and the wet basins. So the utility network allows us to actually integrate and connect the polygon features to the linear network. This is one thing we can never easily do with the geometric network in the past. So how do we create all this wonderful data? Let's take a look and move over to a pond that we want to add, and we want to turn this into a BMP and connect it to the network. So here we have a pond with a storage point in our system. If we go ahead to our utility network tab and we turn on our associations, we're going to see there's no associations in this view. So we can easily connect these outfall locations into our pond. So let's do that by using our utility modify associations ribbon. We can select first our storage point, and then we can select the assets that we want to connect to it, such as this discharge point and this discharge point. Simply hit apply, and that's it. That easily, very easily, we've now created association between these 2 points and this pond location. Now, to connect this polygon to the point, we need to use the containment. So we'll select our container, which is our pond. We'll select the content, which is our storage point, and we want to make it visible, so it's not going to hide it on us. So we'll go ahead and hit apply. Now you may ask, what are these squares that are being shown up as a meta? These are called dirty areas. So the utility network is not being validated all the time as we edit. It's being validated when I choose so to increase performance. So I'll just say we'll validate all our data, and now we'll make sure that we have no errors in our data set and everything's successful and our data is nice and clean. Last thing I want to do is I actually want to generate a new wet basin around this area. So let's go ahead and just search for that. And I'm taking advantage of a capability ArcGIS Pro provides. It's called a group template. The group template allows me to actually build out and generate multiple features at the same time. In this case, I'm building the wet basin polygon, and I'm adding a wet basin point at the centroid, and I could keep extending this to do more complex editing. So by simply just taking a freehand sketch and drawing our area and finishing our sketch, it's going to drop our polygon in, drop our point in the centroid, and to finish that out, I can simply select that new wet basin as my container. I want to select my discharge point as content, select my discharge point as content, selecting the other pond as content, selecting the storage point as content, and the wet basin, and hit apply. Lastly, I validate that to make sure there's no edits, and I've now connected this pond to the network through associations to the outfall, the discharge points. So now when I run a trace, this pond will be connected. Now, when I ran a trace, you might have saw something called which network ran or subnetwork. Let's quickly cover the take a look at how we can utilize subnetworks inside of Stormwater. So I'm going to move over to another area. And here we're looking at our DuPage River and the discharge points going into it. If we turn on our subnet lines, we're going to see some color highlights that differ on each of these different areas. This is different subnetworks that we have set up in our system. The area in orange is called our catchment A. So all features that are part of catchment A will automatically get the information of which catchment zone they're in. So looking at this reinforced concrete pipe, we see that it's part of the catchment A. And these are being controlled by the outfalls that feed that catchment. So if we zoom out a little bit, you'll see we've promoted all these different outfall locations to be this one catchment zone. But on the right-hand side of the river, we'll see we have a different color, and this is actually catchment B. So these subnetworks allow us to determine what are our controllers for our subnetworks in case of catchments, and then anything connected to that will be part of that zone. And this is really powerful. So when we get in situations up here where we might have two subnetworks or catchment zones on a very close border because of elevation, we can see the features up in this area are part of catchment C, and this one's down here, identify, are part of catchment B. How do we generate new catchments? So let's just go to an area up the river where we have right now these features are just part of the DuPage drainage basin. We haven't really promoted them to a catchment. We can select our controller, or we can select a tool that's going to allow us to take this point and elevate it to a controller. We're going to call this the outfall, and if I knew the ID, I'd properly enter it in there. And we'll just call this the demo catchment. Once we do this, the controller will be set, and it simply is running a geoprocessing. First we have to validate, because I did an edit. And then we can run a geoprocessing tool to update the subnetworks. And as this is running, we'll see now, pan over a little bit, we'll see the color change from yellow. It'll change to green, so now it's part of a new subnetwork. All right, so I'd like to, I'm going to turn it back to Howard here to kind of wrap up, and then we'll, turn it over to Nicole for a discussion of how they can take advantage of the stormwater infrastructure for their MS4. But hopefully you've seen how our different templates allow us to, quickly inventory and inspect the assets, as well as, allow us to do more advanced things, taking advantage of the utility network, so we can start capturing the details we need to understand how the stormwater system and the BMPs are connected. Howard?
Thanks, Mike. So just to recap what we talked about and what Mike just showed you, ArcGIS includes 2 stormwater information models and a whole lot more. And what you should have noticed when Mike went from, one of the information models mapping the small water over to, or mapping small stormwater over the utility network configuration, very similar data, slightly different look, slightly different symbols, but very much the same underlying information. And what those do is those provide a framework for organizations to manage information about your stormwater systems. While they're deployed in different environments, right? So what you're seeing is that SaaS deployment, online, PaaS deployment, ArcGIS Enterprise. Both the information models, as I said, are aligned, which makes it easy to go between either environment. So we've consciously built the information models to give you that kind of movement, especially if you wanted to start out smaller and then move into using a utility network. The information models that we're providing are also meant to be extended. So that's that framework concept, right? So if you extend them to fit how your systems are constructed and how they operate, adding in assets that you need to add if they're missing, adding in attributes that are required if there's information you need to track that aren't in the information models we provide. And very exciting for us is they're meant to be extended by Esri partners as well, who can provide you additional capabilities, and that's what you are about to see from Second Nature. So to answer the other question that we started the webcast with, the other question that our team is asked all the time, do Esri templates support MS4? So all those templates we showed you in those information models that are contained within them, do they support MS4? Well, the answer to that is those information models include common man-made and natural stormwater assets and attributes. So you saw Mike showing ponds, right? Green infrastructure, gray infrastructure in his demonstrations. Those assets really provide that foundation for an MS4 to map and inventory the drainage features and structural assets, contained within that MS4 area. The templates that we provide, though, do not include out-of-the-box analysis and reporting capabilities specific to MS4 compliance. Our focus is really more on building the framework, right, and not building the analytics and the reporting necessary for MS4 compliance. But that is where Second Nature, as an Esri partner, picks up on that framework that we're laying down with those information models and leverages it to give you a full MS4 solution. So what I'm going to do is I'm now going to turn this over to Nicole, and she's going to talk to you more about MS4 and to inform.
Great, thanks, Howard. And Mike, I think, did a great job of showing the value of the site scale asset management and mapping that's critical to the foundation of any MS4 program. So I'm going to start with the challenges just real quickly. Nearly every city and county and university across the country has an MS4 NPDES permit. And nearly all of those have what we'll call minimum control measures or requirements. And we've seen kind of a universal siloed approach, if you will, to complying with these minimum control measures, such that program requirements can be spread across multiple departments, and thus the demonstration of compliance becomes reliant upon several people across these agencies. Programs typically also lack an information management system that integrates all the elements of their compliance program. So the result of these kind of silos of data is that when you go to do your annual reporting to the associated regulatory authority, it becomes time-consuming and costly, and it can take months to compile all the required information from all the different individuals that are involved. And so the results become this pile of paper that contains tables and checklists and narratives and static maps. And in the end, we're finding that these annual reports are taking programs and permittees a lot of time to compile, but it really isn't helping you or your team make decisions. So for any MS4s also that permitted areas drain to an impaired water body, PMDLs are putting pressure on these stormwater programs to be more effective. And when I say that, I mean that these programs are having to demonstrate their ability to reduce the impacts of the urban landscape on their impaired waterways that they're draining to. And that's a heavy lift for MS4s, and typically translates, at least traditionally, into a lot of monitoring and modeling expenditures. And so we want to take this approach, really understanding that the benefits of sustainable management of rain that falls on the urban landscape expands well beyond just improving water quality and reducing pollutants to these local waterways, but also that capture and reuse, green infrastructure, low impact development, they all provide multiple benefits to communities that span beyond just the environmental benefits and reducing flooding and improving water quality, but also expand to the social and economic sectors. And that's, Second Nature as identified an opportunity, and we've created a software platform called To Inform to specifically address these challenges. So it's a cloud-based geospatial framework, and it eliminates these stormwater program data silos. We allow you to leverage your existing GIS investment and integrate with your existing data management systems through REST APIs and integration with ArcGIS online groups. So the modules on the right align and look similar to the minimum control measures that are in permits across the country. Actions, projects, and asset information is managed spatially, and it aligns with the Esri utility network data and the stormwater network data model that Mike was showing. And we'll talk about the structural BMPs, but all of that typology is consistent, and we worked with Esri to make sure that was so. But we extend the Esri network by providing users more efficient, precise, and repeatable assessment and inspection methods. The tool serves as a compliance calendar to help you and your team better manage your workflows, which would include when inspections are due, based on the results of those inspections, where maintenance is required, and also helping manage enforcement actions and the information associated with that. We then provide a series of advanced analytics to provide permittee staff with actionable information that empowers them to understand the cause and effect linkage between the urban landscape and those regulated waterways to which they're draining, and manage, in essence, stormwater more as a resource and less as a waste product. So really, we're aiming with this product To Inform to make people who manage stormwater more efficient and their actions more effective at cleaning water. And with limited time, I'm just going to go into the structural BMP module here and give you a little bit more detail. So imagine this is one of those, like the wet basin that Mike had shown. You can record these assets either in To Inform or using the stormwater utility network, and we can digest that data. And like I said, the typologies are consistent. We've spent over a decade now refining those types such that you can define any structural BMP, which is an engineered structure that is designed to accept stormwater and reduce the volumes and pollutants going to it, by one of 16 types. Two people looking at the same BMP are going to call it the same thing. And then there are key specification inputs, as Mike was showing on the screen, depending upon the type, like footprint and drainage area, et cetera. And we use that specification information as well as the relevant design standards to calculate the BMP's expected water quality benefit when it was installed. We then provide our users a rapid assessment protocol series that are both objective and precise measures that output the current performance of each specific BMP. Oops, sorry, wrong direction. And those are all in mobile applications, both on Esri products as well as our responsive app. So we could train anyone to perform these assessments in a day, and it takes minutes per BMP to complete. And the performance then is mapped and distributed. So this is a collection of the structural BMPs within the city of Salinas, and the red BMPs now have a high maintenance urgency. All of the information that we're capturing in this module addresses a number of MS4 permit requirements. So I can go into an automated to-do list here that is helping users conduct timely assessments and inspections and really help you manage your workflows. So what I'm showing here is the identification of where the maintenance actions are needed on these structural BMPs within that population. And that allows the Stormwater Program Manager to focus efforts and understand the resources needed to restore specific stormwater BMPs back to their intended design. Right? If these things work and accept water, they eventually lose capacity, grow vegetation, etc. So they do need to be maintained. And once they're maintained, the assessments are repeated, the restored performance of the structural BMP is documented, and you can just think of this entire module as a green infrastructure asset management system. Oh, keep hitting the wrong button. Okay, so if you do any looking into second nature, you'll learn that we're science geeks. And so what we did is developed and coded an urban hydrology and pollutant loading model into 2N form. And we leverage an available spatial data and land use data sets. And the first place that we start is a baseline load, the total aggregated pollutant load from the city to the local waterways, without any BMPs included. So in this example, it's just under 550 tons per year. And the map is showing the 68 urban catchments that make up the city of Salinas. So building upon the site scale catchment delineation that Mike was demonstrating in the utility, we expand that and do that for the entire MS4 area. And we provide guidance so that anybody with any GIS expertise can follow this and create this network. And this becomes the geospatial framework that's underlying 2N form. In this map, the catchments are colored to show the relative distribution of pollutant loading around the city. The dark brown drainages now are where the greatest water quality improvement opportunities are. And this map then becomes really a valuable strategic planning communication for the city, such that they can identify and communicate where their opportunities and improvement priorities are and why. And so now if we think of all those green infrastructure assets we were just looking at, they all exist within different urban drainages. And these assets, coupled with effectiveness assessments of other select source control and ground control efforts, are used to quantify and track the load reduction project progress achieved as a result of collective program actions. So the idea then is over time, as more effective actions are implemented to reduce stormwater volumes and pollutants, water quality progress is achieved. And the city now can report that progress using both the changing map, identifying where this progress has been made, as well as the load reduction accounting. So you can think of the reporting elements as a stormwater accounting system that is both scalable and testable and technically defensible. So typically pollutant load reduction models are costly and they're complex, but now stormwater managers can have such models at their fingertips, and you can run heuristic scenarios and better understand how to plan and implement a more effective program. And we think this accounting system is going to come in really handy as the EPA and state regulatory agencies ramp up support for water-based markets and require stormwater programs to go to a performance-based program. Such an accounting system also can help you obtain stormwater funding and really answer that question that I posed at the beginning: how effective is your stormwater program at improving water quality? So lastly, just to touch back on the other point of making digital reporting more efficient. Each year when your annual report is due, the permittee administrator reviews and locks their records for the various modules, both program management as well as program effectiveness. And once those are locked, there's a notification to the respective regulator that their annual submission is ready for review. And so then a regulatory portal is available, and that significantly reduces your effort and time and cost to prepare and submit your annual report. So with that, thank you for your time, and check out our website at secondnaturewater.com, and please contact us if you'd like to learn more.
Thanks, Nicole. Mike and Howard, good job. We're going to get quickly to our questions as we're getting close on our time. So let's just start off with a question about the utility network and the demonstration that, Mike, you were showing. We had a question concerning the Stormwater engine, whether it's EPA SWIM or if it's an in-house Esri engine that's been developed. Can you talk about that?
Sure. No, this is actually taking advantage of the utility network, which doesn't model the hydraulics of the network. It is simply there to model the connectivity and how things can flow through it. You know, that information for hydraulic model would still need to take advantage of one of those other software. So we're not building that into this framework or into the network that we maintain.
Following up on that question, is there a capability to do hydrologic or hydraulic modeling?
That's still a capability. We look to our business partners to sit on top of the utility network to take those features and perform that analysis.
And so if I could add, Krista, that I showed the pollutant loading, but also it models urban hydrology. And we have published the modeling approach. So it's comparable to SWIM and HSPF, other typical urban hydrology models. It's called the Tool to Estimate Load Reductions, and I'm happy to provide the publication on how that is done. But that's available within the 2Inform platform.
Thanks, Nicole. Let's get to some questions about cost. So we did have several questions from our attendees concerning cost. Initially, there are several questions about the cost of the application, which I'm assuming means the utility network. Can you explain the cost associated with that?
Howard, you want to take this?
So, well, yeah, I mean, the quick answer is, you need to license both ArcGIS Enterprise as well as the utility network management extension for that. Cost, we really encourage you to talk to your Esri reps on, for that. That's just because we have such a wide audience and some international folks. The cost is really, relevant to the organization asking the question. So the best answer I can give you is ask your Esri sales reps. And if you want more information about the specific licensing required, feel free to email Krista, and Mike and I can get back to you about the actual licensing.
Absolutely. And then concerning the collector for ArcGIS app or the Explorer app that Mike showed, those apps are free of charge. As an Esri customer, you're able to download those for free. Another question specifically about costs, Nicole, this one's going to you. So we have our attendees asking if the 2Inform is available via Esri, or is there a cost to get started with that program? How does that work if they're interested?
Yeah, if they're interested, I think the first is obviously a conversation to figure out which modules are most useful based on your current program and the best way to integrate our solution with your existing efforts and data management systems. And then just generally the cost, it's a SaaS model, and we're scaling the cost by population is really a proxy for your data needs and the amount of pavement and the size of your MS4 program.
Thanks, Nicole. Another question we're getting is concerning the different modules, which I know you said, let's start with a conversation, but can you talk about any module within your solution that allows customers to do entry of actual monitoring data?
Yeah. So again, onboarding into our software is going through and doing the catchment delineation and getting your existing land use and stormwater configuration data in here, which again, there's a great advantage if that's already in here, if you've already done that with ArcGIS products. Then as far as monitoring data, outfall monitoring specifically, we've been very focused in on understanding that, cause and effect linkage between the urban landscape and what is discharged to the local waterways. So there are ways to get outfall monitoring in, but receiving water monitoring currently is a placeholder, and we haven't done that yet. But that is something else that we're looking to as you think more about your TMDL implications.
Thanks. Just to clarify, I'm getting a few comments about the mobile apps. The apps are free to download, but you do have to have an ArcGIS online identity. So you're going to have to log in to be able to use those apps, and the ArcGIS online logins do have a cost associated with them. So our next question is going back to hydraulic and hydrologic models. Are there models from our partners that are compatible with the system and the geodatabase and the utility network that Mike demonstrated?
Howard, you want to take that?
Sure. The quick answer is compatible. Yes, right. Does that mean that there may be some some in between steps that you're going to have to take advantage of them to maybe massage your data to get it into the exact format that the model needs? Yes, right. You may have to do that. That's actually fairly common when it comes to going from GIS into any sort of hydraulic model, right? But yes, you can go from the information models that we've showed and get them into a modeling package. That's also a little bit specific to the way that you're capturing your own data as to what the level of effort is. But it is possible to do that, and that's a fairly common thing to go from GIS into a model.
Thanks, Howard. One more question, and we're going to have to wrap it up after that. Our last question is about the BMP inspections that we talked about during the webinar. The audience wants to know if there are any templates available for Collector Survey 123 that would help them get started with these inspections.
Sorry, it's muted. Yeah, when you deploy the mapping for small stormwater, we provide the inspection forms and we provide the tables, so they're already pre-configured. So I demonstrated them a little bit, but we have the relationships and the services set up for that. We'll still be porting some of that information into the utility network configurations in the future, but they're there as part of the mapping for small stormwater today.
Thanks, Mike, Howard, and Nicole. Great webinar. Thank you, everyone, for joining us. I hope to see you again on one of our future webinars. Have a great day.
Thanks, everyone.